Hey, what's up, folks? Thank you for coming back to the CCNA initiative. Um, the last three things we're going to speak about, and we're still on chapter 9. We're closing out the spanning tree basics and concepts chapter. We're talking about three optional STP features that our CCNA book, the 200-301, talks about. And it's Etherchannel, it's Portfast, and it's also BPDU guard, right? And so these three things are major keys whenever you're building out your switch network, or you guys being at the CCNA level that's watching this, including myself, right? Whether or not I'm at CCNP or what, that doesn't matter. Every network engineer, anybody who's managing a network has to be mindful of these features. Okay, so let's go ahead and start off with spanning tree, right? So we went through convergence, right? We know what that looks like at both regular spanning tree and RSTP, right? We've seen topologies to where it's a single cable between a tree, right, or a group of switches, right? Because again, our goal for spanning tree, we're building on, for spanning tree is that it's going to prevent loops, right? Going through redundant devices, right? So got a cable to switch 1 to switch 3, cable from switch 1 to switch 3, switch 1 to switch 2, switch 2 to switch 3, right? It's all redundant, right? Switch 2 fails, hey, I can still reach switch 3, right? Switch 3 port fails, I can still reach switch 3 through switch 2, right? But, right, the thing, right, about failures, right, convergence, it takes time, right? And what if there's traffic that's passing through, right? Frames that are actually passing through these switches, and we can't afford, convergence to happen. We can't afford, downtime to happen or for that switch to take time, right? Etherchannel is one of the best ways to go ahead and prevent spanning tree convergence, right? So why is that, right? So I just spoke to you guys about just having a single port, right? A single cable between these switches, right? What Etherchannel does, right? You can go ahead and once you configure it the right way, and the next chapter, chapter 10, we'll talk about in detail Etherchannel and RSTP. But what Etherchannel does, it bundles cables up, right? At a software level, right? If you do this in software, you bundle up cables together, you group cables together, right? On different ports to be assigned to a ether channel. And how it works is that they work as if it's one big port, right? One big cable going to another switch, right? That's the best way I can describe it, right? So it acts as if that ether channel interface acts as if it's one big interface. But from a physical standpoint, right, talking about the OSI model, from a layer 1 perspective, it's acting as, it has actually multiple cables between itself and the other side of that ether channel, right? And you can actually have all the way up to 8 physical cables, right? 8 physical cables between one switch to the other to create that ether channel, right? And so a couple of things, and again, a couple of things that have to be fulfilled. First is, of course, they have to be the same speed, right? If they're all 1 gigabits, they need to be all 1 gigabits, they're all 10 gigabits, et cetera, right? And so they're going through the same pair of switches, right? And so the reason why Etherchannel is one big spanning tree feature is because of this. So if a single port fails within that Etherchannel, right? We also have, and let's say we have, looking at the diagram, we have these 2 cables bundled up between each of the switches. If one port fails, spoiler alert, Etherchannel only needs at least one cable, right? One actual connection up, right? For the Etherchannel to be active. Okay? It just needs one physical cable for that ether channel to be active, right? And ether channel, again, this is something that is programmed in software, right? This is something programmed. This isn't something that you buy. You don't buy like an ether channel controller or anything like that. No, this is something that you guys program in software. You have your ports. You say, I want these to be part of an ether channel. Okay. So if you have like you see on a diagram, you have 2 cables bundled between each switch. One of the cables, as you can see with switch 3, one of the cables go ahead and they have a failure, right? Whatever it may be. that ether channel is still going to be up because it still has just one cable connected. One of the rules of ether channel is it's a minimum of at least, by default, one cable. As long as one cable or one link is up, that convergence isn't going to happen. Okay? All right? So that is Etherchannel. And we'll talk more in detail about it in the chapter RSTP and Etherchannel configuration, right? So we'll go over the configuration. We'll go over in chapter 17, right? IP routing in the LAN, and it's gonna talk about layer 3 ether channels, right? Chapter 10 is gonna talk about layer 2 ether channels, but we're gonna also talk about layer 3 ether channels as well, right? And so one thing to note, right, is that layer 2 ether channels, they combine links that switches use as switch ports, right, with the switches using layer 2 switching logic to forward and receive Ethernet frames over the ether channels, right? Layer 3 ether channels does the same thing, right? But those layer 3 ether channels, right, they're using the layer 3 routing logic to forward packets over the ether channel. And we'll talk more in depth. Some of the things that last little Easter egg that I shared, it's out of the scope of the book, right? But whenever we talk in depth and we talk about ether channels, I'll show you guys what that means, right? Because that was a lot in that sentence that I just said. Okay, let's go ahead and move on. So for these next two topics, like I said, well, short topics, I'm going to use the same picture. Okay, so now we're going to go ahead and talk about Portfast, right? One of the second optional features, or one of the optional features within spanning tree, right? And so what does Portfast do, right? And so what Portfast does, it allows a switch to immediately transition from blocking to forwarding, right? So we're bypassing the listening, learning, and the different states, right? And you guys are probably thinking, wow, okay, you can do that. That's excellent, right? However, you only want to enable Portfast, right, on ports that don't connect to a switch, a bridge, right, or another device that is utilizing spanning tree. Okay? All right? Because what's going to happen theoretically, right, if you enable that on a switch if you enable that on a switch that's going to connect to another switch, where we're skipping steps, right? We're not going through any of the checks for spanning tree, right? And we're going to go ahead and it's going to continue to go ahead and go in a loop of, hey, bad BPDU, et cetera, et cetera. It's going to keep going in that loop, and traffic is going to pass, right? So Portfast is more appropriate, right, for connections to end user devices or servers, right? And it's as soon as you boot up a device, right, it's connected to that switch. It's not even gonna see, right, STP, BPDUs or anything like that. It's just gonna immediately get booted up, starts working. As soon as that NIC on the PC or server is active, it's gonna go ahead and get active as well on the switch, that port that connects to it, right? All right. So this is pretty cool. And again, this is just to note take, right? I just want to show you guys. Here is where we would enable Portfast. Okay. And what we call those are downstream ports, or ports that connect to resources or end users' PCs. Okay, that's highlighted in green. All right, so read a little bit more about that in the CCNA. Again, it's a short section. Of course, I'm giving you guys a high level, but yes, it is pretty, something good to implement within your organization, but also, right, something that you absolutely need to know for the CCNA. Okay. Last but not least, okay, let me go ahead and move to the next one. Let me go ahead and erase my drawings. There we go. All right. So last but not least, we are going to talk about BPDU guard, right? And so what is BPDU guards? Well, before we talk about BPDU guard, we need to talk about a few things, right? So spanning tree and RSTP, right? They open up the LAN to several different types of security exposures, right? Example one, right? An attacker could connect a switch to one of the ports on the switch, right? One with a low spanning tree RSTP priority value. We talked about priority and BPDUs and choosing the root switch, right, earlier, right? It can do that and become the root switch. Somebody can just come in with a switch one day to work and just plug it up, configure it at a lower priority, mess up the entire network, right? That's one security exposure, you know. That's potential that can happen in your topology or in your LAN, right? What can happen, of course, you can have a diminishing performance within your local area network, right? Then that's that's worse than what you designed in your topology, right? That you guys actually engineered. Okay. The attacker, of course, a attacker can plug into multiple ports, into multiple switches, become the root, right? And actually forward traffic into the LAN, right? And just bring the actual network down, right? And so, right, best case scenario, we're going to say that the person did know, the attacker did know what they are doing. They are copying, they can copy traffic, they can, because again, what is the root? The root is that central port where it sends data. So it can go ahead and set up a mirror port, right? A port that's mirroring all traffics, right, to one port so that you can go ahead and capture it, right? Little Easter egg. It can go ahead and take all those frames in that's coming in through the switch or their root switch that they plugged in. And before even the network team can realize it, we have exposure. Attacker went ahead and got all our frames, and now they're doing reconnaissance and they're seeing how to do things. And we have an attacker on the hands, and we may have a security risk, right? So that's another one, right? Last example, right, is that again, somebody can just buy a cheap switch, maybe at Best Buy, right? Best Buy, Circuit City. I don't know if Circuit City's around anymore, but just get a cheap switch. But on that switch, right, at the store, right, not knowing it has spanning tree. And we're going to use this example is the example that the person just didn't know. They just want to expand the amount of ports that they have on their desk. So they bring that switch, right, not knowing it has spanning tree. They can go ahead and cause a loop within the network, right? Just bringing an inexpensive consumer switch, right, and plugging it up on their desk, right? Right. And so that's one of the things we need to go ahead and think about, right? Whenever we are planning, right? We are planning our networks, we're engineering our networks, so what have you, is that we need to make sure what are our exposures in regards to security, right? And that brings me to the last topic, which is BPDU guard, right? And Cisco BPDU guard, right? What does it do, right? What it does is all the examples I just gave you, what it does is it disables a port. Keep with me. It disables a port that receives any BPDUs received on the port that has BPDU guard configured. Okay? Okay? So when would we configure this? We would configure this on ports that would never connect to another switch. Same as Portfast. Okay? So, right? If you're going to go ahead and harden, right? Harden your network from a layer 2 standpoint, right? You want to enable BPDU guard along with Portfast, right? Because again, one, your user can plug anything in, right? But if they go ahead and plug in switches, you guys don't have to monitor the users. The switch is going to do its job and say, hey, I understand you plugged in a switch. We're going to go ahead and shut down this port. And then it's going to know, hey, this doesn't work. I'm going to go ahead and have to reach out to help desk or what have you. So these are exciting and great features that Cisco has created for anybody implementing any of their switches, right, in their devices within their network. Okay, so that is absolutely the end of chapter 9. We're absolutely finished. I'm not going to do a lab on BPDU guard or Portfast. I am going to well, let me take that back. I will do a lab. I'll do a short lab And I'll do that tomorrow. What I encourage you guys to do, again, this is chapter 9 of the CCNA 200-301. Please do the chapter review at the end of the chapter. It helped me out when I got my CCNA. Review the key topics, review the key terms, answer the DIKTA, the do I know it already questions, right? Review the memory tables. And again, that's all at the end of the chapter. And then, like I said, we'll go ahead and start chapter 10, which is talking about RSTP and Etherchannel configuration. Okay? You guys have a great day.